This question is very similar to the previous one on the playlist, however it asks for a change in entropy. It says, an oxygen molecule is absorbed on a patch of surface. This patch is known to contain 400 absorption sites. The O2 molecule has enough energy to move from site to site, so it could be on any one of them. So there's basically 400 microstates originally. Then it says, suppose that part of the surface becomes inaccessible, so that only 324 absorption sites are now available for the molecule. Calculate the change in entropy. And then it asks us to round our answer to three significant figures. So we want to keep that in mind. So in the previous equation or question, we used the entropy definition from Boltzmann. Here we want to use the change in entropy, and that is delta S equals KB times the ln of W over W0. So this is the microstates of the final state, and this is the microstates of the initial state. And notice it's delta S instead of S. So this is how it changes. This arrives from, and this is derived in your textbook, but it arrives from the fact that you're subtracting two Boltzmann equations, and when you have ln's and you subtract, that's the same as dividing because you are dealing with exponents. So let's look at how we plug in. To solve this problem is fairly straightforward. Delta S equals, well, KB is a constant, 1.38 times 10 to the minus 23 joule per K. ln of the final state, which only has 324 microstates, divided by the initial state, which had 400 microstates. Divide the numbers, take the ln on your calculator and multiply it by the constant, and you will find that delta S equals to three significant figures, as mentioned in the problem, minus 2.91 times 10 to the minus 24 joules per K. Note that this is the entropy change for one oxygen atom, and this entropy change would be larger if you had, for example, a mole of oxygen atoms, but this is essentially how we calculate this. One last thing that I want to point out is, does it make sense that this delta S is negative? And the answer is, yes it does. The change in entropy should be negative because originally we had 400 microstates and now we only have 324. We have less randomness. So if you go from 400 down to 324 or any higher number down to a lower number, the entropy should be negative. Note that the opposite is also the case. If you had a lower number initially and a higher number finally, the entropy should be positive. It's always important in thermodynamic calculations to double check from the logical perspective what your sign should be.